Hey guys, welcome to DevOpsSchool. In this video tutorial, we are going to learn about Docker. It helps us to create, deploy and run applications by using containers. After going through this tutorial, I promise you that the concept and understanding of the Docker will be absolutely clear to you. But before we begin, let me inform you a few things about us. DevOpsSchool is one of the leading platforms which offers DevOps, cloud and containers technology training and certification programs for freshers and established professionals who wish to update and consolidate their skills in the dynamic IT scenario. We ensure that the training solutions are delivered by highly experienced domain experts with practical working experience in various verticals. You can join our all training programs globally through online platforms, and if you're looking for classroom workshop, then we have regular batches available in Hyderabad and Bangalore. Check out the dates and enroll with us for our upcoming batches. For more info, link and contact details are mentioned in the description below.
So very first thing, whenever you are in the Docker session, you always think about the applications, how to deploy the application across the different platforms, how to ship the application from the one place to another place or one place to many places. Okay, you should not think about the system like, okay, how much RAM I'm going to get it, what is the operating system I'm going to get it, and how much CPU, how much hard disk, all this stuff. That you're not going to consider right now in the Docker session. So it's all about the application. Okay, so let's talk about the applications which we were deploying, not now, 10 years before. Okay, so 10-15 years before, when let's say 15 years before. Okay, so when you were deploying the application 15 years before, what you used to do that? So you used to buy one server, one application, and remember 15 years before our utilization was not that high, correct? So we are not on the cloud, internet were limited with a few people and stuff like that. Guys, are you able to hear me? Hello?
Yeah, I can hear you. I can hear you. That's not a problem.
Okay, cool. Because someone called me and said that it got hanged. That's the reason I asked. Okay, no problem. Okay, so here, very simple. So now how we are progressing. So basically, let's understand. We were using physical servers. Then we started using the virtual machines. We found out virtual machine with one thing which is getting duplicated, which is getting repeated, which is operating system. So operating system also consuming hell lot of CPU, RAM, storage, and top up with the licensing cost. So how can we run applications without multiple layer of the applications? Then we found out the technologies were already there in the operating system kernel level. So that is called user space isolation. So user space is a kind of limit which having certain isolation already, but you have to make the more isolation. So not only you should be sharing the same libraries, we have to make it isolated. So you should be having their own libraries. Libraries means mount system, process map, network, and other thing. So how it is possible? So how that can be made it possible? So here we have a 4 app right now is running on the one operating system. So we need a 4 mounts, we need a 4 process map, we need a 4 network. So the question is how that will be created. So look at this is the mounts. So we need something. So here you have one mount at the physical server level. It has to be duplicated, different one. So container one will be having their own mount system, container 2 will be having their own mount system, container 10 will be having their own mount system. So how it can be duplicated? So we need some technology which can duplicate the kernel's base operating system mounts to the multiple one. How it can be possible? We need some tools or some thing which can interact with the kernel to duplicate the process map also. So each containers will get their own independent process map. We need some tools which can again duplicate the own networks also. So how that is possible? This is being possible with the help of the namespace technology which is there in the kernel already since the inception of the computing. Is there all the time, it were there. So there was a PID namespace which was responsible for the process ID, PID map, net namespace which were there in the kernel for the managing the network, mount namespace which were there in the to create a mounts, user namespace were there to create the multiple users. These namespace were there already. Some tool had just explored the kind of taken advantage and created a duplicate copy of it. Then one question is there, okay, in one physical server you can run multiple app in a simple way, multiple containers which will be completely isolation, and each containers will get the process map, mounts, storage, network, all these things will get it. But how about which container will get how much CPU and how much RAM? Who's supposed to get? Let's say some container need some more CPU and some more app from the base machine. Some container need less. So who can do that? So that also is there. That functionality is also there. Control groups. We call it C groups in the each of these kernel that decide which container will get how much CPU and how much RAM. There's a default setup which has been done. If you want to customize it, you can customize it. Okay. Next thing is which container, who's supposed to get what permission. Okay. Who's inside the each container, who's supposed to get what permission, like who's having root, non-root, all the stuff. So that will be done by the capability. So these were the already cap audit control, chown override cap key. These were there already in the kernel. So now the thing is we need some tool which can duplicate the network, okay, PID, network, MNT, users, permissions, RAM allocation, CPU allocation, and permissions, capabilities. Who can do that? So Docker. So Docker is a tool, okay, which interacts with the kernel. Okay, Docker is a tool which interacts with the kernel. Okay, Docker is a tool which interacts with the kernel basically for the namespace, C groups, and capabilities. Okay, and you know the namespace, C groups, and capabilities is a part of the Linux kernel, each Linux kernel. Okay, so here you have all this stuff. You have a namespace, C groups, and capabilities. Docker basically take the advantage of the namespace, C groups, and capabilities, create a virtual network, virtual mounts, virtual process map, and give it to the container. So each container which is running on the top of the Docker is behave as if they are having their own network, their own mounts, their own process map, their own capabilities, their own CPU, their own RAM, but it is not. Docker engine, Docker is the tool which works with the kernel to make it possible. Okay, and the Docker engine can run anywhere, wherever you have a kernel. Simple. It can be on laptop, AWS, Azure, on-premises, data centers, or anywhere. Docker engine can run anywhere. So in another way, you can create a container basically anywhere, wherever you have a kernel. Okay, so now, did you understand what is a containers? Container is nothing but a kind of completely isolated user space. I'm saying completely isolated user space. Each user space is called as a container. Each container will get their own network ID. They will get their own process map. They will get their own network storage mounts. They will get their own permissions. Each containers can behave as if they are independent, but it is not. Basically, Docker engine is making facilitating all this stuff with the after interacting with the kernel and duplicating it and making it feel each container as if they are independent. Is that clear? What is a container?
Rajesh, one question on this one. You said it's logically it's isolated between the two containers. How about the security? For example, if I go on if I got a root privilege on this one, is that doesn't mean that I've got an access to all the containers, because how is the security measures have been handled
Yeah.
between the
So
containers?
basically, here if you look at this, in the host machine, you have an n number of containers running. So the host machine can communicate with the each container because this container is running on the each of the host machine. So security, whatever is there, there's so many mechanisms in which you can secure the container. But as of now, if the containers is running on the host machine and host machine is compromised, everything is compromised, because each of these are the user space in a certain kind of user space in a complete isolation. So host machine should be very protected, and there are more ways also practices in order to secure the containers. I'll tell you some of this later.
All right. Okay. Sure. Thank you.
Any other questions?
Hello. Hello.
Yeah, tell me.
Hello. Yeah, is that the Linux is a prerequisite, or we can use the Windows also as a base
Yeah.
machine?
So yeah. So as of now, it's supported both Windows and Linux. But when Docker introduced, they only supported the Linux. Okay. So the thing is, let me just talk about it here. So here, if you have a Linux kernel, you can run only the Linux app or Linux containers into that. You cannot run the Windows container in a simple way. Okay, but if you have a Windows kernel, you cannot run Linux app. You can run only Windows container, because both of these kernels are different. So Linux container, Linux app; Windows container, Windows app. Simple. Is that answer your question?
Yeah, means as per now there is no hybrid.
There is no hybrid means.
Means for only one container service we can use one Windows container on same machine as well as a Linux container.
Uh, so the scenario is very simple, because you know that containers is very attached to the kernel through the Docker engine. So if the Docker engine, if is adhering the capabilities from the Linux kernel, it will create the Linux container only. When Docker engine
Okay.
will inherit the properties of the Windows kernel, it will create only Windows container.
Okay. Okay. And what will be the licensing for the Windows kernel? Means Windows is license based, no?
Yeah, so actually what has happened, when Microsoft realized that the Docker and container technology probably killed them, so they have released the free version of Docker's 2016 base operating system. On top of it, you can run the Docker container, and I believe that is a free of cost without any charge.
Okay. Okay.
And you don't need a full-blown EU operating system. You just need a kernel, Windows kernel or Linux kernel.
Okay. Yeah.
Rajesh, for example, if you build an container on Linux kernel, the same container cannot be accessed on Windows kernel, isn't it?
No. I said one thing. When you run the Linux container, you cannot run on the Windows container. Sorry, Windows engine. In a simple way, if I put it, see, you create a container which is the Linux app. Let's say you have some operating system Ubuntu, okay, and top of it you have a JDK. Top of that you have a Tomcat, and top of that you have your application. This is your one kernel which is running on the Linux. Now Ubuntu is the base machine to run that particular kernel, so it cannot run on the Windows kernel, because Windows kernel and Linux kernels both are different. But Ubuntu can be learned on the any Linux kernel. That's possible.
Okay, okay. So if we have developed one application on a Linux kernel, we can't shift it on to Windows kernel.
Yes, very well.
Okay, that's what pro thing for the container, no? In if we have developed any applications, that should be a cross platform.
No, it's not should be cost. I'll talk about this. Okay, let's understand this thing. Remember one thing. It's obvious because it's like this. When you understand how the Docker engine and container works, this question will go away. Remember, what is the work of the Docker engine? Work of the Docker engine to read the Linux kernel for the namespace. Okay, remember namespace. See, what is the work of the Docker engine? Docker engine will read the namespace for the namespace for what? Namespace for this, process map, networks, mounts, user space. This will for the namespace. Now, Docker engine will read the C groups for the CPU and RAM. Docker engine will read the Linux kernel for the capabilities, and same will be replicated with the to the multiple containers. Is like a virtual network, virtual process map, virtual mounts, virtual capabilities. So simple. Docker engine will have the Linux kernel. Of course, it cannot support the Windows container because Windows containers behave and act differently. Getting my points?
Okay. Okay. Yeah. Yes.
Okay,
Yeah.
but
You can
there's
proceed.
some workaround also. What you can do if you want to run Linux container on Windows or Windows container on Linux, what you can do on Windows, let's say you install the hypervisor, which is VMware or VirtualBox, you run one VM, and inside that VM, you run the Linux operating system. And on top of it, you run the Linux container. So basically, you are
Container.
running Linux container on the Linux itself, but that Linux base kernel is running on the Windows using the virtualization technology.
Okay. Okay. We have to introduce one more layer if we want to work on the Windows machine.
Yes, because I said Docker engine can run anywhere. You can run on the VMs, public cloud, private cloud, laptop, or anywhere, wherever you
Okay. Okay. Yeah.
are. Okay, so this is the guy who developed the Docker. Solomon Hykes is basically the first company name was .cloud. That later it got renamed to the Docker. This is written in the Golang and with the Apache. This is the Apache copyright. That means a free open source product. Anyone can use it and stuff like that. Okay, so now we have understood what is a container. So containers are not for the virtualization, and they are using resources of the host machine only. When you talk about the resources, then you know that network, process map, mounts, capabilities, CPU, RAM, they are using everything from host machine. So if your host machine is capable, your containers will be capable. Okay, so now let's get started the next phase. So we have to install the Docker. So let's understand some of the things before installing. Okay, so when you install Docker, okay, usually we call it Docker engine. Then in the each Docker engine, you get the two important tools or components, and this is called Docker client and Docker daemon. Okay, Docker client is the one where you pass the command, and through APIs they send to the Docker daemon who will execute it. Okay, so that's important. So Docker engine consists of two elements: Docker client, Docker daemon. Okay, Docker daemon is running in the host, and Docker client through REST APIs you send the instruction to the Docker daemon to execute it. So literally, Docker client you have in the one host, and Docker daemon it can be another host also. But if you install the Docker engine, both of these will get in the same host. But it is possible you can keep it in the Docker different host also. Here Docker need roots. Okay, that's important. So Docker, remember, Docker is the tool which is the interface between your kernel, base kernel, and the containers. So if the Docker is running without root, then you will not be able to get the containers running, because they will not be able to duplicate the process map, mounts, and all this stuff, right? So Docker need roots. But if you are not the root user, what you can do, there's one group called Docker in the system where you install the Docker engine. You just add the normal user to that group called Docker, and it can be possible. Okay, so that is also possible. Okay, here again we are talking about the Docker engine. Here you have a two Docker daemon actually. And look at this, how can you have a Docker client, Docker daemon? So by default, Docker client resolved to the same Docker daemon in the same host. But if you think that Docker daemon you are running on the different host and Docker client you are running on the different host, then you have to export this one variable to the Docker client, which is called Docker_host. And you have to give the IP address and the port number which you are running using by default 2375. Okay, so first of all you have to go run the Docker engine with the not local host but to the IP address and the port, and run in the background. And after that you have to tell your client saying that this is your host, this is your Docker daemon which is running on the different machine. Okay, so that is the one thing. Okay, anyone who's not able to hear me, I just got a WhatsApp message.
Yeah, Rajesh, sorry for the interruption.
Yeah.
Sorry guys. Can you explain one more time where the Docker daemon and client will play here, please? One more time.
Yes.
Yeah, just understand this concept. I will tell you it during the demo.
Okay.
Yeah. Anyone who's not able to hear? Patankar?
Yeah, I can. I have restarted. Yeah, I can hear you.
Okay, fine. So let's get started. From now onwards, I'll give you the demo. Okay, so let's get start the demo. Not more slides. So what I do, I just said you can run the Docker engine anywhere in your laptop, in your desktop, wherever you want it. I am using one of the EC2 instance. The reason is very simple. The speed of the EC2 instance and internet, broadband, everything will be superb. So demo time will be reduced drastically. If I use my laptop, probably end of the day also I'll not be able to complete the demo. So I'll go with 1 GB, one machine here. I'll go for 30 GB storage. That's sufficient for me. Go for this. And my machine is ready. This is my machine where I'm going to show you the demo. IP address. I'm waiting. Username is ec2-user. I'll make this view better. Here. So I hope everyone is able to see that clearly.
Yes.
Okay. So now I just said Docker need root, so I just install the root. Okay, so now I am going to maintain this nodes here. So we have understood few things: what is Docker and how Docker works, and then also what is container. So this is already explained. Now how to use it, I'm going to tell you right now. Okay, so first thing, how to install Docker engine. Okay, so before I would like to tell you Docker engine, Docker ecospace. Okay, let me put it in a different way. Docker ecosystem. So they have a various kind of Docker ecosystem. One is which they released Docker. Okay, they released the very first time they released Docker. Okay, after that they released the Docker engine. Okay, after that they released Docker community, and after that they released Docker enterprise. Docker enterprise is a hosted solution. This is a hosted solution. That means in the cloud. Okay, so you can use it whenever you want it. It's a cloud hosted solution. Probably you can privately also host it, and this is a paid software. Okay, so this is the paid software. Now if you want to get this done, you can ask for the 12 hours trial period. Okay, and you can get it done. Look at this here. Okay, so here you see this try free cloud hosted trial and stuff like that, so you can try it here. Okay, so this is a trial version. You can get it for 12 hours right now. Earlier they used to give it, I believe, 3-4 hours and stuff like that. Now they have increased to 12 hours. Okay, now you don't need to know this one for using the Docker community which you should install, or Docker engine which you should install. So I'm going to install the Docker engine. Docker anyways is a deprecated, so it's not anywhere. Okay, so each we'll use this one, Docker engine. Okay, now there's one question. The question was, how about Swarm? So Swarm I'll talk about the end of the session. Swarm is not a part of our course. Why? I will discuss later. Okay, now here we got it. Now the question is how to install Docker engine.
How you become root by AWS client, AWS users, sudo -i you have done?
Sudo -s. Okay.
Okay.
Okay. What I want everyone to focus on my training, my demo. Please do not try to run it those commands parallelly, because the reason is you will understand, miss the concept, you will be having the big gap. Okay, but if you understand the concept, you will be having the recordings. You can do a lot of times. Okay.
Oh, yeah.
Yeah. In fact, I'll provide the notes for you also. Okay, so how can you install? So there you can find the instruction hundreds of places how to install the Docker, but what I have done, I've just consolidated the installation procedures and kept it here. Okay, so you don't have to run many places in the Google. Just come to this place and get it done. So now I'm doing the same, I am following the same in front of you, so you should get the things. First thing you should update, but I'm not doing the update because it will take some time, and for timing I don't need it also. But some operating system you need to update. So now I run this repo where the Docker engine is lying. Okay, it will go and create a repo in the yum repository. So I just copy here from here and then got it. Now I'm going to install the Docker engine.
Rajesh, the whole point of putting the repo here is all your images is going to sit on the place where you're defining. Is it what is the step is involved actually if you're defining as this process, like prior to just installing the Docker services? The repo is you're keeping a place where to keep all the images and containers. Is that my understanding correct?
Sorry, just I missed your questions altogether.
Now, the earlier step, what you've done, the repos actually, what is the point of significance of keeping that? Is that keeping all your repositories or all your images and things like that? Or the earlier step, what you did just now, what is significance of that?
Okay. It's very simple. Here I am installing the Docker engine through yum. Okay. Now the yum by default will not be having the Docker engine software. So if I add this repository, I'll get the software of Docker engine from this location.
Okay, this is fetching the software, not to keep all your containers and images in that place. It's
No,
just to
I'm
fetch
not
the
talking about the
binaries from.
containers at all. Okay. Now Docker engine, I am going to enable it. I just enable it. I have not started it. Remember, I have not started it. So what I want to show you one thing very clearly. Look at this here. I'm going to write it, but you have to observe. Thus again, I'm saying please observe the things because there's so many things I have to show you. Now, before start, Docker engine start. Okay, I just run if config. Look at this. I have only one Ethernet 0, and this is the interface. Okay, now only Ethernet. Now I'm going to start the Docker engine. So I will note it down this one. Okay, now after the Docker engine start. See that there's one Docker 0 has come, which got introduced with the start actually. Okay, now this Docker 0 is the network related services. Okay, the moment the Docker engine start, all the networks will be provided, all the containers IP address will be managed through the Docker 0. I'm not digging out into the depth of the networking with the Docker, but remember, whenever you start, Docker 0 is a one bridge which will provide the IP address to the each containers. Okay, this is managed by the Docker engine. Okay, so this is the which I wanted to show you. Now, very simple. If you want to start how to use the Docker. Docker is very simple if you understand well. If you want to start with the Docker, you have to install the Docker engine. Remember, why do we need an engine? Because it can interact with the kernel and manage all the containers and provide the mounts, network, security, process map, C groups capabilities and all this stuff like that. Do you know that? Clear?
Yeah.
Now, remember I said all the time app. Forget about the servers. You always think about the application. So this app will be nothing but will become coming from the images, packaged images. How to create images I'll tell you later, but let's not get lost. So packaged images. So this is the images which you have app. Third thing, you need a registry. Here you need a registry, the registry or repository. Okay, so what is a registry and repository? So the place from where you download the images, the place from where you download the images. Simple. Now you have a package repository which can be public, it can be private. So if you have a public repository, the public repository is very simple where you can get this hundreds of images. You see that? Just read this. 1 lakh plus free apps. So this is the public repository. Okay, this is the public repository. Here you can store if you want the store. This is free. This is paid. Okay, so here you can get the repository images. Hub.docker.com, the images, which is free. Anyone can get it. But here you can pay for the images, and all are certified images, signed images, trusted images. You can get it and then use it. Now you can have their own repository also using the Nexus Pro, Nexus OSS and Artifactory Pro. Artifactory OSS is not having the Docker image things. So now this is also, you can create your own things. So Nexus is a part of the training, so some of you might have gone through that. So you can set up your own repository using Nexus or Artifactory. So these places you have images, you download the images from these places, and then the last one which you need to know, containers. The running state of the images, the moment you run the image, it become a container. Simple. Okay, so from one image you can run infinite container. Infinite. The limitation is only host machine. Simple. So if you want to get started with the Docker, you need to know what is a Docker engine, and just now I installed it, and you know that what is a Docker engine now with the discussions also. And then application, you need a package images. Okay, I'll name it images. Okay, images you can download from any of these places, or you can develop your own images. I'll teach you. And then the moment you run the images, become a container, and then from one image you can run the infinite containers. Okay, is that clear?
Yeah.
Is that clear?
Yes.
Yeah, sounds good.
Yeah, so first thing, I need to get the engine, and I showed you how to get the engine, and I have already started the engine. So now the first command we should run, the very first command you should run, docker info. Let me run. I lost the console, so I've relogged in. So first command you should run docker info, and info will give you the lots of information about your system, like how much containers you have, how many runnings, paused, stopped. So these are the container information. I have none. I have 0 images. This is the version of server. This is the storage driver. So the volumes you can see, network, bridge, host, MACLAN, all this stuff. Kernel version is you are using here. The operating system is, this is the architecture. 2 CPU, 2 and all the stuff like that. Memory is 4 GB. All this information. So first thing is this one, and second thing is Docker health. Okay, so Docker health will give you all the commands. So Docker health, and here you see that all the commands are given. You have, these are the commands which I'm going to use anyways. Okay, so now I'll put it here. So these are the commands which I'm going to show you the demo for it. Okay, simple. Now any other commands? No, you don't need it. So now I got this. The Docker engine is set up properly. There's no problem. So I'll make it this as a done. Okay, any questions so far on the Docker engine front?
No.
Okay, next thing, I need images. From where I need images? So before you need images, you have to decide one thing. What images? What application? Remember, it's all about application. So what application you want to run it? Okay, so what application? So I can use, because I don't have an access, I don't have Artifactory, I cannot access to store.docker.com, I can access to hub.docker.com. So I should go to hub.docker.com, forget about rest of the repository, and I am searching one image which is Jenkins, because it's a very popular application. So let's look at this. Here you have a Jenkins images. You can see these many repositories being referred, huge amount of it. So here you get two kind of images. Okay, two kind of repository. One is called official and one is called public. So if you get the official image, that means this images has been created by the people like the company itself. So Jenkins itself is owning this repository. But if you see the public images can be uploaded by anyone like you and me, and we'll do that upload in some time also. Okay, so anyone can upload these images also. So public images is like, you have to be very careful if you're using. If you're very confident, then you can use it, but against condition. Look at this number of stars and number of pulls. Based on the number of stars and number of pulls, you decide which images are good, which images are not good. Okay, so you see that the less star, less pull, that means you have a problem in it. Okay, so just be mindful about it, selecting the right images. I'll go with the public image, official image itself. So I click on it. Now this is the image. Here we have short description. This image got deprecated, but no problem, we can still use it. This is a Jenkins, how to use these images and also further. So the question is how to download images, and the answer is Docker pull command. So I want to download the images, which is called Jenkins, Docker pull Jenkins. So now let's look at this and how to see the number of images. Okay, so Docker images is the name of the images. And now you can see there's no images, so I'm downloading the Docker Jenkins. Now it's downloading the, see, look at this here. This is downloading the layers basically. What exactly these layers? Latest, pulling from library. This is the one, this is the second, this is the third. So basically this image Jenkins is nothing but a one. It's not a one file basically. It's a multiple file. Look at this here. 1, 2, 3, 4, like that is growing. So what exactly? So have you anyone worked with a Git?
Yeah. But first, one question: how you have made communication between hub and your local repo?
As I said, to begin with, this is the public repository. So there is no authentication required. If it is a paid, then you will be prompted for the user ID and password. If it is an access, you will be prompted for the user ID and password.
But you have made your account, no, first on hub.
No. It's a public repository. Anyone can download the images.
Okay, means there no need to create an account.
No need to create account. See, simple. If you want to download, nothing is needed. If you want to upload, user ID and password is needed, which I'll show you at the end of it.
Okay.
Okay, so one thing which you just missed it, it's not a one package. Remember, it's not one package. It is a multiple files, and these files. So have you gone through the Git? Anyone who have not gone through the Git training or Git experience with the Git?
I've worked somewhat, but I haven't full-fledged work.
So it's like this. If you see the Git log, you see the multiple commit ID. Something similar you are getting here also, right? So just hold your thoughts for that some time. I'll answer this question in detail, but not now. But understand this. Jenkins, a Docker pull Jenkins is not a one file. It's not one file which is consist of the image. It is a multiple file. What are those multiple files? You can identify using this unique ID, and basically it's pulling. In Git also you pull. Here also is being pulled. Okay, so now you just remember, we'll discuss, come back to this topic later point in time, but for time being, how to get the images, simply pull. And I just did pull. Now Docker images, I run this command, and now I have got the image which is called repository Jenkins, tagged with latest. Image ID is this one, created 4 weeks ago, and the size is 801 MB. Okay, so this is the one. Now let's get
so Rajesh, image is like basically an application.
What is that?
So image is basically an application which we desire to do,
Yes,
right?
yes. Images has the application which is called Jenkins right now.
Okay, okay, yeah.
Okay. So now let's get the IP config again and process P also. So what I'm going to do right now, I am going to run this IP config. Okay, look at this here. Docker 0 eth. So now I'll note it down. Docker 0 eth. So Docker 0 is created by Docker engine, and LO, which is an interface of virtual machine. So this is basically for the system. This is for the Docker. Now I want to run it. Process map also. See right now, Docker sock is running here. The services which is bind to the root. This is the PID, PPID. You can see this here. A shock is hitting now. So now how many total output you have it? This one. So I want to show you this list. So before running the containers command, I am hitting this one. After running the containers command, I will tell you. I'll show you. So you have to observe actually all this thing, because commands are damn easy. Just you need to observe. So what I do, I have a good Docker image. The question is how to create a container, how to run the images, how to get a container. Let me put it, how to get a container. Now the question is how to get a container. So I said, remember, the moment you run the images, where is that? Here. The moment you run the images, it become a container. So now I have to run the images. So here, how to get a list of container. So if I do clear the screen, Docker ps, I have no command, no containers. So Docker ps. Now how to create a container? How to create a container? So I have to run an image. So now the question is how to run the images. Let me ask you. The question answer is Docker run. But the thing is, Docker run is a command. But what are the parameters you need to give? You need to ask to the image developers only. Okay, only image developers. Right now, in order to use this image, they say you have to run this command. So Docker run is the remain same, is the command which is remain same. Now what is this? What is this? What is this? So in order to run the container, you have to, in order to run the container from the image which is called Jenkins, you have to run this command. So you have to understand this. So here I'm telling you, Docker run will do following. Check if image is there in local. If not, download. That means it can download again. That means it can perform the push operation, pull operation also. Okay. Next thing is you have -p. What is this -p? So basically, let's understand here on the notepad. End. This is your machine which I am having. Inside that, this is IP address. Inside that, I am running the Docker engine. Okay. Now, Docker engine is running one container and running another container. Docker engine creating the network here, mounts here, all this thing from the base machine. Okay, so now this machine will be having their own IP address. This machine will be having its own IP address. This machine will be having this container, sorry, not machine, will be having their own IP address. Now these three IP address will get from the Docker 0, which I showed you here. But let me not confuse you. If I run this application, you know that Jenkins is needed two port. Jenkins is needed two port to run it. One is a web port, which is 8080 by default, and one is a node port. So Jenkins master itself is acting like a one node. So you need to assign that to also some port. So here let's talk about 8080. Inside that it's running Jenkins. Okay, it's running here. Here also 8080 is running. Inside that 8080 is running. Wonderful. You can access it. If you get inside the container, you can access it. The problem here is I am here. I am the human being. I am at here. I am not inside the container, and I need a browser. I need to access it. So how to access the container here, which is running on the 8080 port here, 80, because if I cannot run it on the host machine because it's only one port is allowed. So for that, what I do? Expose. So expose this port base machine 8090, expose this machine to 8091. Okay, so that way I can access it. Is that clear? So we need a two port, one port for the internal, two port for the external. So here if you look at this, here you have a first one is external port, second port is internal. Is that clear?
Will you please repeat once again, right, this concept?
So this is the base machine. You have a containers running, each of these containers running on 8080 port. Now you want to access over the browser, so you cannot expose the same port 8080 because host machine will create a conflict. So one 8080 from the internal you are porting to 8080, another 8080 to 8090, another 8080 to 8091, something like that. So each base machine has a different port. So this one is the external port, this one is internal port. This one is external port, this one is internal port. Is that clear?
You need to say that the host machine have constant 8080 as an external port, and 8081 is the internal port for the Docker container.
No. You have not understood. Nothing you have understood. So let me show you the demo first. Okay, not explanation mode. Okay, very simple. Now let's go here. Here Docker PS, I have no containers running. I have been instructed if you want to run this container, you have to run this command. I'm not running this command at all. I am running the command which is called -d because I don't want to lose the console. If I run the up command, remember, you will lose the console. Why? Because I am not adding the detach mode. Here you will not lose the console. So here I'm adding this command. Okay, remember. So clear the screen. Docker ps, no container is running. I just got one container. Okay, Docker ps. Now I got the one container. Remember here, container ID is this one, which is the same similar short form. Is from the which image? Jenkins image. Inside the Jenkins container, which command is running in the background? This is the one created 4 seconds ago. What is the state? Is up from the 3 seconds. What is the port? So here port is this one. Okay, this is the port. So right now 8080 is mapped to the 8080. How come? Let's figure it out. What is the IP address of host machine? 8080. See, this is the Jenkins. So this is the external port. This is what I was talking about. So now and this is the internal port. Okay, now let's rerun this command one more time. Again, see that what has happened. Error response from daemon. Driver failed. What is a driver failed? External connectivity on the endpoint, infallible, something like that. This ID, and it says port is already allocated. So bind failed. So bind failed because port is already allocated. So now if you see this Docker PS, still you have only one container running. But if you do the Docker PS -a means all container, now you got the two containers. One is running, another one is created. So this container, because I ran the command, same command again, the containers got created, but it did not run it. Why it did not run it? Because the port was already bind. Okay, so this is called external port. This is called internal port. Now if I want to run another container from the same image, I have to change the external port binding because internal is hard coded. So yeah, just change it, and now I rerun it. See this
That external port is
Docker PS. Now we got the two containers. Now see, containers 1 is accessible on 8080 port. Container 2 is accessible on 8081 port. So let's verify. See, this is another application which got up and running within a no time, in seconds of time. So this is the port mapping. Is that clear now?
yeah.
Okay.
It's like a small general doubt. Why we are writing 8080:8080 and again 5000:5000 two ports?
So Jenkins required the two ports to start the services. One is a web server port and one is a node port. So this is not related to Docker. This is related to the application.
Okay, 5000 is
So
the application.
8080 is the web port. That means this is a web port. Now each Jenkins, I don't know whether you understand the Jenkins, but it required the nodes which runs on 50,000 port internally.
So 50,000 is also an external port.
No. Do you know the Jenkins? How many of you have no idea about the Jenkins? And you don't need to know the Jenkins first of all to learn the Docker. Very simple thing. There is one application which is Docker, which is Jenkins. Jenkins need to, in order to run the Jenkins, you need a two port to be running internally. So here 8080 port which you can browse it for the web port, and 50,000 port for the node port. Very simple. One application can use 10 ports also, 20 ports also, depend on the architecture. But the problem here is,
got it.
Yeah, the problem here is you can run an 8080 and 50,000, no problem. The problem here is I will not be able to show you on the browser. That's the problem. So in order to show you in the browser, I need to expose it. That's what I was talking about. So I need to expose it. So -p is the way to expose it from internal to external. From internal to external. Okay.
So for any application, we need to do this porting thing, or
What is that?
this applies one. So for any application, we need to port from internal to external.
No, not again. I'm saying the same thing again. This guy needs the two ports to be mapped it up in order to application. If you have some application which you don't have any ports running, it's not required, then don't use it. Simple. So as a one thing I said, right, in order to use the images, any images which you are using, you have to ask their developers how to use it. They will tell you.
Okay.
Hello?
Yeah.
Hello? you have browsed that application using 8080 port from web browser.
Mhm.
Yeah. Instead of that, you have using 5000 port, the same output will be given.
Okay, let me explain one more time. This is your base machine. Okay, now here you have a containers running. This is a Linux machine. Okay, now you tell me, I don't have a browser here. Do you have a browser in your console? Tell me yes or no, at least.
Yeah, browser. There is a
Yeah.
browser. Yeah.
Yeah. So how can you access this on the browser? You need IP address and port number.
Yes.
Okay, 80 is the port default, and any other ports also you can do the 80, 80, 80, 90, whatever. Now you have one application running inside the container 1 on 8080 port, which is internal to the container. Here also you are running 8080 port, which is internal to the container. Here also 8080 port, we are running internal to container. You have a 50,000 again, which is internal to the code. So whenever you run Jenkins, you run the master and slave. Master runs on the 80 port, slaves run on 50,000 port. Okay. So now it's running internally, all this thing running internally. Now you have to
Okay.
access it over the browser, not on the console.
Oh,
So
okay.
you can't map it. See which one you are hitting, you don't know, because all ports are remain same.
Yes.
Correct? So in order to, you have to map it. Map it means expose that. This is not a Docker technology. This is a application network concept. Okay, so you have to expose on the different port. So now I decided I will expose one on 8080 port, another on 8081 port, another on 82 port, like that. Is
Two
that
port.
clear?
Yes. Yes.
Yeah. Any confusion so far, anyone?
No.
Okay, so now you saw that my containers is running. I have got the two containers, one containers, two containers. Wonderful. Now remember applications, one app, two app, from the only one image, which is here. Two external IP, external IP. This is, you don't need it because nodes is required, so you don't need it. Okay, so now, so this is clear. Now let me put it this one also. This is web port for the Jenkins, web for Jenkins, node for nodes. Okay, now if I log into the Jenkins server, it says unlock Jenkins, and there's one password which is at this location. If I want to continue further, I have to unlock this Jenkins. So how to unlock this Jenkins? So let me go and let me close all this remaining stuff. I'm running two containers, remember. I lose this console. Okay, so now if you look at this, Docker PS, I'm running two containers. Okay, Docker PS -a, I'm running. Which will display all the container, running container and exited container. So right now we have two running container. One is created, which you can see that. So PS will give you only running containers. Okay, so now let me write it down. List of running container. How to get a list of all container. There's some typo in the notes, please ignore it. Okay, so now, okay, now what I wanted to show, yes, I wanted to unlock this Jenkins so I can proceed further. But do you have a file in the host machine? ls, no file. So where exactly this file is there? This file is there inside the container. Okay, so inside the container you have, this is inside the container, this is inside the container, this is inside the container. So how can we go inside the container? Okay, how can we go that? So the command is to get inside the container is docker exec -it for interactive, and what container you want to get inside. I have to get a list of it first. Docker exec -it, and what container you want to get inside. Let's say you want to get inside 8081 container, and here what you want to do inside the container in bash. So how to get inside the container that is called docker exec -it cont id, and what you want to do inside that bin bash, because if you go without bin bash you will be a problem whether bin bash is there or not is this question. So just to always go to the bin bash. Now see, at root at the rate of da Jenkins at the rate of da. This is your container. Okay, so right now you are inside the container. Now you see that inside the container these are the process running ps-ef. See that this means I'm inside the container. These are the process running. Remember, this is the same process which was shown here. Look at this. Okay, so now you got this. This is the container running, but I came for grabbing one file which is called 8081, this one. So more, this is the ID. I put it and taken, and installation configuration started. I don't care about the Jenkins. I'm not teaching you Jenkins. Just understand. So how to get inside the container? This is the way. How to come out of the container without exiting. The container. So how to come out of it? Control E Q. Okay, this is the one. So right now I just type Control E Q. Let's see, you are got outside of the container. So now one is solved. So Docker PS, still you have two containers running, and this is the way get inside the container. This is the outside of the container. Now if excuse me, if I type ps-af again and grep for the Docker, look at this. Look at this. So here I wanted to type this command. You have to understand. Earlier, you have to notice very carefully. Each containers create one proxy. Okay. Earlier it was not there. Look at this here. Earlier it was there. See here. This is the output. Okay. So each container create one proxy. Okay. Here, and each container is running on this. So basically you have to understand all this thing very carefully. Analysis, each container you run, basically you are running this container process in your host machine only. Okay, now you want to see that IP config, if config. See, each container is still resolving to Docker 0, but all the time you get the more you container you run, see, the more interface you get it. See, this is the interface. So you have to notice all this thing, because it's the same. See, resources is being used same from the host machine itself. There is no resources which is coming from the outside. Okay, they're using the same host machine. This is the interface, this is the bridge, all this stuff. So now we have got to know the basics of the Docker. I'm not going to confuse you with the too many things, with the too many at the first class itself. So simple thing. Are you clear how to download the images? Are you clear?
Yes.
Did you see
Yes.
how to list out the images? Do you see how to know the list of running container? Did you see how to list of all the containers? Did you see that how to run the containers? Did you see that how to get inside the containers? How to come out of the containers? That is what I want you to get started with. So now let's move on. Okay. So now we will divide all this command into the two part. Okay. And from now onwards, I'll go a little bit fast. Okay. So we will divide. So what I did, I will divide into two parts. So let's do this. Exec images info logs ps pull rename So I'm dividing into the two part. The logic I will tell you in some time. Let me divide it first. So okay. So I have divided all these commands into the two sections. And I will name it very simple. Managing the containers. This is the command. Managing the images. This is the other. Okay, so let's get started with this. So now here exec command is we use it in terms of run a command in the running container, and I have just done it. I wanted to get inside the container and run this exec command. List command I have already tried and showed you. Info command already I have told you. Now let me quickly get inside that. So docker ps is the command in which I'm having two containers running. I want to inspect. That means I want to display every information about the particular container. So docker inspect the container ID, and here you see that this container, which you can see, this is ID created at this path argument state right now is running. This container got created from these images. Okay, all this network related information, see this is bind to 8081 5001. Okay, and what is the IP address of this? IP address you'll find somewhere here. Look at it. So this is the IP address of the container. Okay. Now, what is the bridge mode which you had it? Sorry, this is not IP address. Sorry, this is a gateway. This is IP address. Okay. This is the gateway. Now, this gateway is Docker 0. So each container is getting their own IP address, though we are in the same machine. Okay. So now you can inspect. So Docker inspect, you can use Docker inspect. You can use and cont ID you can write. In fact, you can write image ID also. In fact, you can write network ID also. So anything you want to inspect, you can do that. Okay, that is possible. Now, next thing is logs command. So now, if you want to, how many containers running? You have see, I am having two containers running. So I want to see what is the logs of these containers. So Docker logs and container ID. This is the logs. Okay, so that way you can fetch the log of the container ID. Very simple. So Docker logs cont id. Now you want to see next thing. Let me clear the screen. Next, you want to see this is a Docker. Okay, there's one way you can get inside the container and see the list of process which is running. I just did it using the exec command, but this time without getting inside the container, you want to see the list of process which you are running. So Docker ps command and Docker top command. Docker top command which will tell you the list of processes which is running inside this container. Okay, so right now there is a 3 process which are running inside the process which I have shown you inside the container also. This is the process. Okay, so now this is the process which you are running. So Docker ps is done. Docker top is the Docker top cont id. Okay, if you have any questions, do let me know. ps command already I have explained it to you. Pull command already I have explained it to you. Okay, let's try the rename command. Before that, I want to try remove command. So here you can remove one or more container. So let me show you. Docker ps, I have a 2 containers running, but if I do Docker ps-a, I have one container which is running, not running, which is created but it's not running. So I want to clean up this container. So what to do? Docker rm and the container id, and then now Docker ps-a, now you have only 2 containers. So that way you can clean the containers whichever you want. So Docker rm is the doc cont id, you can clean the containers. Okay, now next thing, Docker rmi, you want to delete the images, but unfortunately I cannot delete the images because I have only one Jenkins image and that internally is running the 2 containers. If I delete the images, it will not allow, first of all, because these images is being used to run this containers. So here I need a different images. So let's download the different images. This time Docker pull, and I'm downloading some of the images using Ubuntu. Remember, Ubuntu is the operating system, but for the Docker is application. Okay. So for you it's a operating system, but for Docker everything is applications. Okay.
Does two container ping each other in Docker?
Yes, because Docker 0 is the common bridge. So any containers which you have used for that particular bridge, you have associated with the particular bridge, it will ping each other. Okay, I'll show you. Before that, let me hit see. So now you have a Docker pull Ubuntu, and you can see Docker images here. You have 2 images. Now I want to delete these images. So Docker rmi, I am not running any container out of it, and images which is Ubuntu, I just delete. Now you see that all the layers got deleted. So here Docker image, you can use it. Docker rmi, I stand for the image, and image name or image id, whatever. Okay, one question which you have asked me, that each containers can ping to each other. So I have a 2 containers running. Each of these containers, let's find out the IP address quickly. Inspect is the command which will give me the IP address of this container. So IP address is 1.172.3. So let's ping this IP address. You see that it's pingable. Now next container is this one, and the IP address is 2. So let's ping this 2 also. See, each of this container, it can be pingable. Now let's go inside the container and try to ping it. So the container ID is this one. So Docker exec -it, and then which container I want to go inside this container, and then what I want to do, bin bash. I need a console to run my command. Bin bash. There's a spelling mistake. Exec. Now I'm inside the container. Now I ping 172. Oh, what was that? This 1 and 3. Let's ping. See, 2 is pinging. Let's ping 3. Says pinging. So basically, it's in the same host. Your
Gateway.
Yeah, gateway is the same, so you have no problem. So Control P Q. I just come out of this container, and wonderful. Okay, so now Docker PS, I am having 2 containers running. Let's try another command. So now rename so let's rename it. So if you look at it very carefully, right now under the name section, you see this name which is generated by the Docker engine, which is not making any sense actually. You don't know what exactly that the sense. So if you want to customize the name of it, you can do very well. What you can do, you can create a container with the specified name. So how can you do that? Let's do that. I'm running the third container this time. Okay, and then this time I'm going to name it hyphen name SCM Galaxy. Okay, this is the name, and I'm going to put it this command. There's a problem, port allocation problem. I made it problem, so I should have made it 20 8082 and then 2, same problem which I had earlier. So now okay, then this time port problem, this time the name problem, because the name was already got used actually. If you see that this image got created with that same name SCM Galaxy, so it could not create it. So I have to clean this one. So Docker RM and then container ID. Okay, so clear the screen. Now Docker PS -a. I have only 2 containers. Now you see that container third is also running, but this time the first 2 container is running with a random name, but my container right now is running with the SCM Galaxy. So this is the way you can name it. The question was to name it, not rename it, right? So how can you rename it? So simple. You have a container which is running, so you can rename it. So Docker rename, and then what is the container which you want to rename? My container which you want to rename, this guy, which I don't like the elegant name. So this is the container, and what is the name? SCM Galaxy 2. So this is the command which you type it and just do that, and now you see that SCM Galaxy 2. I rename it that container also. There is one question, let me answer. How can we see what is the port allocated? How can you see what is the port allocated? First thing, you can see through the inspect command. Okay, inspect command. Let me tell you, port is as application specific, not container specific. Port is specific. So Docker inspect, and you do the container ID will tell you which ports is allocated for that. So also you can see Docker PS. I don't know whether you notice or not so far. Here this is the port. Okay, so all this thing you can see that. Okay, now let's move on. Now PS command is covered, pull command is covered, rename command is covered, RMA command is covered, run command is covered, start. Okay, so very simple. There is one container. Right now I am having 2 containers, 3 containers altogether. So I want to stop the 2 containers. So let's stop. So I'm going to stop this container. I just stopped the 2 containers. Now you see the Docker PS command. I am having 1 container running. Suddenly I decided, okay, let me up this 1 containers. So I'm going to start the container ID only 1, not 2. So I'm starting this container. And now you have a PS. Here it is. So now this is the way you can start and stop the container. So let me update this commands also. Docker start cont ID. Okay, and Docker stop cont ID. Okay, so this is the way you want to know the status of the containers. That means how much CPU, how much RAM is being used. Docker stats. Okay, this will tell you have running these containers and how much CPU is being utilized by this container and this container. CPU, RAM utilization, network utilization, all these things. So basically Docker stats will give you very good information about this one. So Docker stats will give you the resource being used by the containers. Okay, now there's one command which I want to tell you at the last one. How to copy the files from the one place to inside. So from one machine to the inside the container. So right now you see that there's one file which I create, rajesh.txt. Okay, this time I'm using the other container. Okay, so let's download. So first thing what I will do, Docker stop I'm stopping the container. Docker RMI, but RM, not RMI, RM. I deleted the container, so right now I am having no container. Look at this here. Docker PS, no container, PS-A, this one container. Let me get rid of this one also. And here I just get rid of everything. So now if you do that PS-EAF grep docker, see that it's gone. All the network, all the processes is gone because I deleted. Now you see this if config, all the interface is also gone. See that? Okay, so every interfaces in every process is being created in the host machine only. Okay, so now I don't have any containers, but what I do, let me check how images are. The images are there. I need a different image, so docker pull ubuntu. I'm pulling the ubuntu image. Okay, now I got this Ubuntu image. You can see the Docker images. I got the Ubuntu images. Ubuntu image not needed any port. Remember, don't need any port. Why? Because this is the operating system. Jenkins was needed a port. So how can you run it? So this rule you have to remember. Rule of the container. If you don't remember this rule, then you will not be able to work with the container, because I have not told you so far because I did not find it useful so far, but now we need it. Containers must have at least of one process running. If that process is not running, then container die. In absence, container die. So what is the meaning of it? So if you look at this, I'm creating one more container using Jenkins. I just created Docker PS Jenkins container. Now see this process running. Okay, this process running PS-EF grep Docker. See this process running. Okay, now if this process is gone, so this is the process ID. So this process is gone, then Docker PS top and container. Oh, sorry. Okay, this is the process running Docker top, which is the process running. See this. So here you have a two process, main process running this one. So if this container is alive because of this process. Now let me show you Docker run Ubuntu. What happened? You have a container? No, you don't have a container, but is it created? See carefully. Yes, Ubuntu containers got created, ran it, exited it. Because why it got exited? Because this rule applies. That process must be running. If any process, at least one process not running, container dies. So basically this ran, exited, because there was no running process for it. So what to do? So now I will just clean this container first. So Docker RM, and this time I will create one container using the same Ubuntu, but this time I will hold it. So I'll make it interactive. Okay, and here I will hold it with the bin bash. Now see this container, I am inside it, I'm holding it, and what is the command to write it and then come out of the container without killing it?
Control PQ.
Yes, but I'm not writing that command. I'm not trying that command. I just type exit. Remember, the moment I type exit, bin bash exit will do what? It will kill the bin bash process. You see that again containers got exited because bin bash, I write the exit command, it got exit. But this time I will do one thing, docker exec -it, and this time I'll go inside the docker container, Jenkins container, and then I'll do the bin bash. Look at this, this is the difference you have to understand. Right now I'm in the Jenkins image and I type exit. See that nothing has happened. Why? Because for this container, there was an already in build process in background which was running bintini, which was holding this container. So exit command did not do anything for that. But here in this container, there was only one process which was a bin bash and it was holding. So the moment you type exit to the bin bash, it exited and container dies. Understood? So one process has to be there in running state to make the containers alive. Did you understand this?
Yes.
Okay, so now docker ps-ea, I will delete the remaining containers. So docker rm, and the container ID is this one, and this time docker ps-a, I have only one container, so now I am going to get one more container using the Ubuntu. So this is the container I get inside that. I got the containers created. You can see that control PQ. I got it safely exit. Right now you see that bin bash is holding this container with the help of the control PQ. I did not exit this bin bash, so that's the reason it's holding the container and it's running the container. Okay, so this is important rule of the container. If you do not understand, you will be having the only half understanding. So basically, yes, why I got this container Ubuntu, because I wanted to copy some file. So let's do one. Can I copy a file from the, so I am having one file which is called rajesh.txt. So I want to copy the file from Rajesh, just a second, give me 2 seconds. Yeah, so basically what I was trying here, I was trying to copy the file from the base machine inside the container. So right now if you see that my container is Ubuntu and my file is in my base machine which is rajesh.txt. I want to copy this file into Ubuntu. So how can you do, and you have to decide where you want to copy. So first I will do one thing, I will go exec versus attach. This is the beauty of it. Okay, remember here is one command, attach and exec. So just look at this, docker top and the container ID. I just did, remember, one time exec. Okay, so now what is the container running? What is the process running? Look at this. Now I am having the one process running which is a PTS, pointer terminal 4. Now if I do exec one more time with the same IT and same container and then bin bash, remember same container, exec means it will get inside the container and it will run the container with the specific commands. Okay, so I'm just doing, again I get inside the container and control PQ, come out of the container, again top. Look at this. So this time terminal session 4, it was there earlier, it got 5. So each exec will create one terminal and create a new session in the container. Okay, are you getting me? Okay, guys, are you there?
Yeah,
Yes.
it is there. Actually,
Yeah.
good.
Yes.
So each exec command will create a new session inside the container. Remember, the sessions also consumes little bit of CPU and RAM. So this is not a good practice. You have a container sessions running already, so you should not create more container. You can do that, but you should not. So what is the best solution? Docker attach. That means Docker attach will attach to the existing session itself. So now Docker attach I just did it, and now you got attached to it. Now you see that, and here you can do whatever you want. And if you do the ps-eaf, now you see that still you have only two containers running, two terminals running. Right now you attach to the one. Okay, this is the one. Okay, so this is the way you can minimize the more session creation in the container. So exec will run commands inside a container with new session. Attach will get attached to the existing session. Did you understand?
Rajesh, but I don't, understand this attach command very well.
What is that?
I don't understand this attach command very well.
Okay, you don't understand the attach command, but do you understand the terminal concept in the Linux?
Yeah.
Okay, so terminal, so right now, how many terminal you have it here? Tell me. If you look at this, how many terminal sessions you have it here?
One terminal?
No.
3.
Here you have a two terminal. PTS4, PTS5. Okay, if I do exec IT again, and what is the container ID? This is the container ID, and bin bash. How many total terminal I got activated? Total 3 terminal. Remember, each terminal consumes CPU and RAM. So control PQ, instead of creating every time a huge terminal, you do the attach to the existing terminal. It could be 1, 9, 20. So by default it will get 1 if attached, because this is the first process. Okay, so Docker attach, what is the container ID? Now what is your terminal? Right now terminal is, yes, see, this is my terminal, which is this one. So instead of creating the different session, different terminal on the each exec, you can attach. So here I say, if you want to run any command, again I'm repeating, if you want to run any command inside the container with the new session, use the exec. If you don't want, if you want to attach the existing session, use the attach. It will save CPU and RAM. Is that clear?
Oh, yeah.
Okay, good. Now what I was trying to do, yes, I was trying to copy the file. Okay, so now I control, no, before that I'm inside the container and I will go opt directory. Remember, it's a Docker engine is creating a duplicate copy of everything, like mounts also. You see that inside the container, every mounts you have it. Look at this, dev, sys, etc, dev, all this thing, every mounts you have it. So right now I am creating, going opt directory, there's a empty, there's no file. You can see that I'm inside the container, there's no file. Okay, control PQ, I get outside of the container. Now I am having the rajesh.txt. So what I do, I want to copy this file. So docker cp, you can copy file directly, anything, but which container I want to copy inside this container, but which directory I want to copy inside this directory, and done. Okay, now attach again, no exec. Now you go to the OPT, sorry, see this file is there. Okay, control PQ, I come out of the container. Right now I will delete this file, so rm -rf. So I copied the file from the base machine to the container, but how can I copy from the from inside the container to the base machine? So for that, docker cp again, but this time source is a container. So this is the container, and I want to copy rajesh.txt to the current location, and here you have it. Okay, so this is the way you can copy the files using the cp commands. Any confusion here?
No.
Good. So the more you see the scenarios and try, then more you experience, because this is new technology. It will take time. You have to practice it. Without practicing, nothing you get it. Okay. Now restart command to restart one more container which is stopped actually. So it's not needed. So we have almost covered the managing the containers. But now I am going to talk about how to create the images and manage the images. So these are the commands which you have it. So let's move on. Any questions before that?
No, sounds good
No.
to me.
Rajesh, one
Okay.
small question. What is the difference between like Docker run and start?
Okay, Docker run will always create a new container. Remember, a simple statement. Docker run will always create a new container. Docker start will start the stopped container. Got it? If you type
So
10
Docker
times
run.
Docker run, 10 containers will be created. But Docker stop, we require the existing containers to be there.
Got it.
Okay,
Thanks.
so now let's move on. So now we are creating images and we will try to use these commands. So before we getting started how to create images, let's understand a little bit of the images. Okay, so how the images are being built. So let's understand. So you have downloaded two images actually, right? You have downloaded two images. One is Jenkins, one is Ubuntu. So how that is possible? So basically you have seen that the moment you download the images, you get a hell lot of layers is being pulling out. Pulling this layer, pulling that layer. Those are the like with unique identification number. So basically images in Docker is made of the file system layer over each other. Okay, so you have a file system layer 0, which is the bottom one, and then top of that layer 1, top of that layer 2. So it's like this. Let me put it in this way. No, let me show you the image first and then I'll explain it to you. So that way it will be. So now images is consist of the multiple layers. Each layers you have a changes. It can be changes anything. You have a file system changes and all the stuff like that. So if you see that any images, you have a 0, which is the first layer, and you have a top layer which is the image 2. So this is the image 1. Each layers can have a different changes. So if you look at this image here, you have a base image, okay, which has a Ubuntu operating system, which I use just now. On the top of that, you do something like Nginx installation, so you get another thing. Then you top of that you updated the operating system apt get update, so you updated and it's become a layer 2. So that is how that it's happening. So images, the container is consist of the multiple layers, and that is how it happened. The moment you run the images, it become a container. So from the one image you can run a multiple containers, so base will be one. Okay, so that's the one thing, is very exciting. Now what is a container? So if you look at this image, you will get it. Here we are redefining the definition of the containers. Containers is nothing but a writable layers. Okay, so if you look at this, images is consist of the locked layer. Okay, so I should go back and draw the things in a simple way rather than confusing you. It's very simple. Today I have started doing Ubuntu image. You have used the Ubuntu image? Wonderful. So now this is the Ubuntu image. This is the base image. Base image. Now I created a container out of it. So the moment I created a container, remember, this will create one new layer which is called read and write layer, and this will be read only. Okay, from here I create one more container, I get one more layer which is called read and write. Okay, so this is here I create one more container, again I get more. So basically image is a read only, but they create a new writable layers where everything you do. So that is the reason, if you see that here you have used you see that here you have two containers. So basically two containers has created two layers, and the layer ID is this one. Okay, so now if you see the Docker inspect and this container, so now see this container is based on the images which is called, see there here. Okay, so this is the images. Okay, now so if you want to do the number of layers which is of the images, very simple command, docker history image name, so Ubuntu. So these many layers you have it in the Ubuntu image, but right now you are using one container which is here. So basically this container, this layer has been created on top of it. Okay, top of it. So this is how which I am talking about. So now one image is nothing but a consist of layer. It can be one layer, it can be multiple. If you convert the image to the container, you get the writable layer. Actually this is where you do the changes. This is where you do the changes. Okay, now if you commit this layer, then your image plus this layer, it become a new image. Are you getting my points?
Yes.
Okay, so let me correlate with the discussion with the Git. How many of you have understanding of the Git?
We picked up something actually in the last.
So no more understanding. Okay, so actually the Docker, simple thing, let me remind you, Docker and Git works in the same way. Why? Docker concept of image and Git concept of staging is the same way. Why it's the same way? You have some of the commands are similar also. Why? The reason is very simple. Both are using SHA-1 algorithm. Okay, SHA-1 algorithm. So Git is also based on the commit of the changes which is done in the staging. Docker is nothing but layers, which is writable layers, which is containers. The changes are in the writable layers, and the moment you commit the changes in staging, it become a layer. So let me not confuse you too many things. Simple things. Image is, what is image? Image is consist of multiple layers. Each layers, first layer contain the base operating system, subsequent layer contains the changes which you have done, contains the changes, file system changes. Okay, are you getting more points? So one image, you talk about any images, you have a multiple layers. The first layer is a base image, subsequent layer contains the file system changes. Last layer here, if you run the image, it create a read and writable layer on top of it, and that's your container. Is that clear? Guys, are you there with me?
Yes.
Yeah, it's pretty much clear. Sure,
Okay.
thank you.
Now, how I'm not sharing lots of information because I need a few hours of discussion to dig out each and everything, but in a simplest way I'm talking about. Okay. Now here, next thing is how to create images. So if you want to create images, there's the first way. using existing container. Here again I said images are read-only layer, combination of read-only layers. Okay, so how can you create images using existing container? And second, using Dockerfile. And both of the things I will tell you now. So how can you create images from the existing container file? Please watch my screen very carefully. I don't want you to miss this any steps. If you have confusion, stop me immediately. Okay, let me get into the duplicate session. EC2 -user. Oh. Here. Now, Docker PS. How many containers I am having? This is the container. So I'll get inside the container. So this time no exec. I will do only attach. Okay, I get inside the container. Now, do you have a git inside the container? No. So I will do apt get -install git. So see, git is not there. Why? Because the update is missing. So update. Update is done. Now git will be there. I'm installing the git inside the container. Be mindful about it. The container is from the Ubuntu base image. Okay, now do you have a git here? Look at this. Git, you have it. Control PQ. Now you know that all the commands, so I don't have to explain you again and again. Git you have in the base machine. See, there is no base machine. But if I go inside the container, I have a git. I can use it whenever I want it. Okay, and control PQ. Very simple. So now the thing is, I want to take this container. This container is from the Ubuntu base image. So this is a layer which got created. So every changes has happened in this layer. Okay. Now I want to create one image which will be having Ubuntu plus Git. So which to commit? Of course, this to commit. So in order to commit this one, you have to use this command, commit command. So let's do that. Docker commit. And I forgot the exact syntax, so I'll do this here. Okay, here is a Docker commit options. So Docker commit an option, in that I will put message. This is my Git image. This is my Git plus UB. UB means Ubuntu. Okay, now what is the author name? So author name is Rajesh. Okay, and what is the container ID? See this container ID. So my container ID is this one. Where is the container? Here. And now what this container ID you want to name it what? So I'll name it ub-git. Very simple. See, Docker images. You got this. So you got one image with Ubuntu. You got another image with Ubuntu plus Git. So here the size was 113. That has become 243. Did you see that how it's easy to create images?
Yes.
Yeah. So now what I am saying, images is combination of the read-only layers, is a locked layer. Images consist of the multiple layer. First layer always contains the base operating system. Subsequent layer which contains the file system changes, which I did in this case Git. Okay. Now if you run the images, it will create a one writable container. In my case, writable containers was having Git, and I committed it and become its images. So this image again it become a read-only layer. So now I have these containers. Let me clear everything. So Docker PS, Docker stop. You have to stop before clearing off. So here, and Jenkins also, let me get rid of it. Okay. RM. Here it is. So now Docker PS, you got have nothing, Docker PS -a, you got have nothing, but I have a 3 images. So now you decided one with the base Ubuntu, one with the UB-Git. So now I run it. Remember, I'm running it. Each run will create one command. Run, and what run? I'll make it interactive way here. And what I want to run? Bin bash. You want to run in the background, you can do IT also. ITD also. Now you got it. You see the Docker PS. This container is running with the background process of the bin bash. Okay. Now you see that this container is running. Okay. Now I get inside this container. Let me show you. Remember, this is from the Ubuntu. Git a Docker attach. Here I get inside the container and I type git. There's no git. Control PQ. I just come out of it. Now I will create one more container from the images, which is called UB. So UB-Git, the image will become a UB-Git. UB-Git. Now container is created. Now you see that two containers running, one from the Ubuntu, one from the UB-Git. I get inside this container, Docker attach. Now you have a Git. So Control PQ. This is the one of the simplest way you create images using the Docker command. Any questions so far? Any questions so far?
No, that's fine. Absolutely.
No, this is good.
Okay, so this is the one. Now next scenario is again simple, but what happens, see, this scenario commit we do not use very frequently, because what happens, that image process creation we want to streamline across the projects. Like we have a dev team, we have a QA team, you want to streamline all this stuff like that. So you want to you want to commit, rather than you want to use it Dockerfile, using Dockerfile. So Dockerfile is the file in which, let me show you this. I'm just skipping the lots of discussion because I believe this is not needed for time being, because of this crash course. But again, if you practice it, that's not a very difficult. So here, modifying existing image I just shown you, and here you have to have a Docker file. So what I do, I just copy this stuff. Okay, now using the Docker file, so there is all the specification. Let me write it this one. All the specification you write in the Docker file. File name is Docker file. Let me put it. File name is equal to Docker file. It can be anything else also, but for time being, let's not practice something which is beyond our basic understanding. So the file name is Docker file, and inside that you write the instruction. So what is a Docker file? Docker file has a list of instruction. Remember, instructions. Okay, now you need to understand this instruction. For that, I must share with you one tutorial. You can get all this information in Google also, but I have consolidated it, so it's just good reference. Oh, it's not here, probably I can need to push it. No problem. Tutorials, Docker labs. So okay, it's here. My bad, I was looking at the different URL. So this is the right file, Docker image 3, which is on the portal Docker image 3. This is the one. Yep. Okay, so now let me explain it to you. So I said, very in the simplest way, Docker file, this is the second way to create images, is using the instruction. Okay, so instructions you can put it in the Dockerfile. So what are the instructions you can put it? So these are the instructions you can put it. First thing, you have to try from. So what is a base image? Remember, each image should be having the base image. Okay, so base image has been given by the Docker itself. It's easily available. You can type it. So if you want to know the list of the base image, just Google it. Don't have this question in your mind. List of base images in Docker, and Google hub.docker.com has the base images multiple. See, these are base image. Look at this. They have total see here. Okay, so this you can use it. Ubuntu you must be part of it somewhere. CentOS is here. Hello World is here. So like this you can have a base image. List of base image. Probably that was not the right things, but I'll show you this one. Let me change the list of base image. This is the probably it's a nice one. See here, official images, all images from the Ubuntu repository. Ubuntu is the one, OpenSUSE is the one, CentOS is another one, BizDevOps is another one, Tyon something is like that. Here you have Arc, here you have OpenSUSE again. So these are the base image which Docker has released. Okay, so every time you are going to select the base image. If you want particular base image, only that particular version you have to write it this. So from means base image. Who is the guy who's maintaining this Docker file? So this is me. Now what you want to do inside the images. So now this is the where you have to understand carefully. So now you have an instruction. These instructions are like add, CMD, entry point, environment, expose, from, maintainer. From this means base image. Maintainer means who are you? Okay. Run means which is the command you want to execute during the creation of the images. Remember, I'm not talking about the containers at all now. I'm talking about what is the command you want to run it before creating the images. So run. Okay. What is the entry point? Entry point is something like the process. I said no, one process has to be there in each container to hold that particular container. So how can you pass it through entry point or CMD? Okay, how can you map the volumes using the volumes? How can you set the working directory of the containers? This is the one. How can you decide which user should be used to run the container? User. So these are the things you can do that. So best way to look at this is I'm going to show you one image which you have used it already. Docker Hub Jenkins. This is the image you have used it already, so no need to worry. Now I click on the Docker file. Look at this here, Docker file. Using this image, this file itself, this image which has been created. Okay. Now it says from. They are using OpenJDK. OpenJDK. Basically, they must be having. You want to trace it down? No problem. Let's trace it down. So Docker Hub OpenJDK. See, this is the image they have used it. Base image. But this base image, if you look at this. This is a tag. This is a tag. So this is the Docker file. Just a second, guys. So now if you see that your Jenkins image is from the base image OpenJDK tag number 8-JDK. So I came to the OpenJDK, which you can see, and hyphen number 8-JDK. OpenJDK is the image name, tag, and this is the base file. This base file, this image has been taken from the another base image which is called Alpine. Let's go and hit the Alpine. So Docker Hub Alpine. Okay, now this is the Alpine image. Alpine, what is the 3.7? So now 3.7. So where is the 3.7? Here it is. This is the Docker file. Now this image from the scratch. So look at this here. So this is a scratch, and your base image is rootfs.tar.xyz. This now, what is a rootfs? So this is your base kernel file. This is the file. You want to download this file, you will be having this file somewhere here. See, this is the file. So this is your basic Linux kernel. Using that, it got created Alpine image. Alpine image has been used in the OpenJDK. OpenJDK has used this image in the Jenkins. Did you understand this relationship?
Yeah, interesting.
Yep. So now you see that here I am taking the base image Ubuntu because I'm not taking anything else. So here from Ubuntu, maintainer, who am I and what I want to do. So basically I did manually this one. Remember, I did manually apt get and apt install git. I did manually in this process. Same thing you have to provide through run. You want to create few directory, run. Okay. So these are the instructions. These instructions, you have different instructions. So I was showing you here, this is the file, Docker file of Jenkins, which has been used. Look at this, what they have done. They have taken the base image from here, and the moment they take the base image, they want to update, apt update. That means it's a Ubuntu. This file system which I was showing you, this is a Ubuntu file system. Okay, so update, installing git, curl, again removing some file. Arguments means setting up the variable. So in each programming language, you have a way to set up a variable. In Dockerfile, you can set the variable like this, and you can use this variable, use the Docker sign, dollar sign, using everywhere in the program. Look at this. So if you think you have one variable which will be used across the multiple times, you set the variable using arg. And you can use it with the $user, $group, $uid, $gid, $http port, $agent port. Okay, so this is the way to set the thing. Now, whenever the containers will be running, this environment will be set: Jenkins home, Jenkins slave, agent port. I don't know whether you notice or not. Let me see that quickly. So Docker engine, I lost this console. Docker images. I'm having Jenkins image. Let's grab the copy of it. The command ATO81. Now you want to see that environment variable of this. So Docker PS. Here you have this one. So Docker inspect this container, and you have Jenkins home must be defined somewhere. You have to search. See, user is defined. See here, user Jenkins. So they have defined the Jenkins user. User is let me show you here. Here, user is $user. So what is the value of user? User is Jenkins. So they have set here user Jenkins. Okay, like this. See here, Jenkins home. So running containers will be having definition. So here what they are doing, setting the environment variable. Again running some of the command, maybe creating a group and stuff like that, attaching any volume. So the moment you attach to the containers, you will get inside this one. You want to check var Jenkins home. Let's do one thing. Let's go Docker exec -it, and what is the container ID? This one, bin bash. See, pwd, excuse me. See here, I just cd, type cd means go to my user home, var Jenkins home. So var Jenkins home. So this is the way you set it up, everything in the Docker file. Again run, again env, again run. Here you are copying the file from the current location to the inside the images. Okay, again setting up the arg environment, arg run, env run, expose. Because of you have to expose 2 port because of this reason. See here, they're exposing the 2 port. One is HTTP, one is agent port. 80,000, 80, 50,000. Again setting the environment copy, and because of this entry point, this container was not needed any additional process, because they have said, okay, run this process in the background, always inside the container, and copy some file. So the moment you have this file ready, you have to spend some time to write the better file. Okay, and you have hundreds of each of these files reference you can see on the github.com. So this is the simplest one. Okay, so I'm taking this Ubuntu as this one and this doing the same thing, putting it in the Docker file. Let's do that. Control PQ, clear the screen. I create one directory, doc cd doc. Now vi Dockerfile, insert, here it is, save it. Now the command is build. Okay, build, and this is the image. So image name, this is my account name, this is the image name, you can put it ub-git2. Okay, version 2 you want to tag it, where's your images, dot, and this will create the images, another image, the name of the images will be SM Galaxy ub-git2.
So Rajesh, a quick question.
Yeah.
So I'm using, I mean, so we have multiple layers, and right, I mean, in a container. So you have a base layer, and on top of it, I have my other layers. Actually, I'm using it.
Yeah.
So if my base layer gets any updates, uh, am I just taking a snapshot at that point when I'm building it, or do I have to, get any updates actually later as well?
See, a simple thing. You do one thing. You plan your things like this is a CentOS, okay? CentOS base image. After that, install JDK. You take now another image, JDK.
Okay.
After that, you install the Tomcat. Take another image. Now, which one you want to modify? And after that, you install the application. This is another image. This will keep changing every day. Okay.
Right.
Now, if suddenly you decided to do the technical, it's just a stack upgrade, then you have to modify this base image. If you want to, you have to what do you say? Decided to upgrade the JDK, so you have to modify this. So you have to, and now again base, then you have to modify this. So this is a logical things.
Okay.
Okay. Now you see that Docker images. I got this images created here. I just ran it simple, and I need an interactive, otherwise I'll lose this. So IT, and let me do D also in the background, and IT should be running with the bin bash, right? So others, because Ubuntu is not having any process, so I need to give the one process to make it alive. Now there's a problem, the image is not found. So okay, the image not found because the tag is missing. By default it will look for the latest, but mine is not latest. So now you got created another image from the Docker ps. See this here, this is the container. So this is the way you write the container. Any questions so far creating the images? Any questions? Anyone?
No.
Okay, good.
Rajesh, one small doubt.
Yeah.
So, Rajesh, so if you want to write a new image, so then we'll be using the Docker file. And in an application, there should be only one Docker file, or we can have multiple Docker files.
It's up to you. Up to you. You depend on the technological stack or application stack. It's up to you. You can have n number of Docker. You saw that I was traversing to the multiple Docker file in order to get the series, right? See, different version, different Docker file.
Okay. So the structure should be each folder one Docker file, right? Like in a single folder, we could have.
No, you can name it with a different name also in the same folder, but right now I did not talk about it. If you have to give the different name, then you have to, instead of dot, you have to give the full path of the Docker file.
Okay. But the only naming convention should be suffixed with the Docker file.
No. You can keep it any name, XYZ, MNP, whatever it is.
Okay.
It should be having the instruction. If it is having instruction, which is in this format, wonderful.
Okay.
Okay, guys. So now I told you how to create images. Before that, I told you how to consume the images. Now, last topic, how to share the images. Okay. So how to share the images? First thing is local way. Second thing is hub.docker.com way, public repository way, and last one Nexus way. or artifacty way. So I'll teach you only first two. Okay. So now local way. That means how I have one image. Let me tell you how can I share this image. So let's go here, clear the screen. I will get rid of all the containers to have the clear environment. So ps docker stop all the containers. Okay, I just stopped all the containers. I'll remove all these containers again. Now I removed it in front of you, nothing is there. Now Docker images, I am having 4 images, 1 2 3 4 5 images. So I want to take a backup of this image. Okay, so how can you share the local ways? Through FTP or SCP or SSH or whatever it is. So I have to save it, this image. So Docker save, where I want to save it, I want to save it -i, and file name would be pack or anything. You can keep it, you can keep it this one also. You name, you can keep it anything. I not O, actually sorry, O means output, and it should go into tarball. Oh sorry, tarball of what? Tarball of this guy, and v2, and I'm creating one tarball. Okay, and now tarball is ready. See, this is the tarball. If you want to know how the image is being created in the layers, untar it and just see that carefully, study it. You have to spend a lot of hours, and then you get it how this each image is being structured and meta file is being written. That's a good exercise for all of you. Okay, you have to do that. So now I don't care right now, but I am deleting all these images. So RMI this image, and then v2. I deleted all of the containers, so that image is deletion is not a problem. Now you see that I don't have that images in front of you. So now how can you do that? Docker load, and I'm acting like a different person. I have got this tarball, and through SCP, through FTP, whatever it is, Docker load, and then -i is not needed, I guess. Let me try without that, and it's needed. -i, and here Docker images. See that this image is there. So now you saw that how can you share locally those images if you don't have any platform and stuff like that. Is that clear? Is that clear?
Yep.
Clear.
Okay, now next scenarios, how can you do the local hub? So let me tell you, hub.docker.com, anyone can go and create accounts, so no problem in it. So anyone can go and create accounts. I have got the similar way. I have got the one account which is called SCM Galaxy. Okay, now SCM Galaxy you can create. I have got the user ID and password, Rajesh. Now this is the place. Let me tell you, one private repository you can create is just like a GitHub. Okay, nothing great, just like a GitHub. So one private repository you can create free of cost, but public repository, as many you want to create it, is free of cost. Okay, so I'm creating a repository. Name of the repository is like what is the month? April doc. Okay, the name of the repository April doc. This is the description short. This is, sorry for typo, I'm just trying to complete the topics, all this, so it should not be missing. So long description, this is a short description. April doc, public repository I created. My path would become this one. Let me tell you the very simple thing here. The image name, Docker images, the image name should be matching with this image name. Okay, so my image name or repository name is the same Galaxy April doc. Here in the local, you do not have anything related to that. So let me rename this one. So how can you rename this one? We call it, the process is called tag. So Docker tag from here to the here. Tagging. Why is copying not? Tagging. So now I just tag it. Now you do the Docker images. I got the another image reference. See, I got this one from this one. Both are referencing to the same image ID. Look at this. Okay, there. So now I am going to upload this one. I cannot upload this one because the matching name repository should be matching. So here the repository and the public hub repository should be matching. So first thing, what I'm going to do, Docker login. Login will ask you the username. So I think my username is RCM Galaxy. Password, I don't know. And then I logged in. Okay. Then after that, Docker, earlier I used to do the push pull. Now I'll do the push. And push of what? This one, not this. Is that? This one. So, and by default it's the latest. If you want to push any other tag, you have to keep it like this. But as of now, it's latest. So Docker push. I'm pushing it. And push is happening, and you get it under the tag option. See, there's no tag has been uploaded so far. We'll refresh it this page after the push is done. It's done. Now I will do one thing. I will delete locally. I'm acting like a different guy. Excuse me. RMI. I just deleted. You see that this image is not there in your local. Now simple, refresh this page. You have got the 109 MB repo info, and now how to pull it, you know that. You don't have to, I don't have to teach you now. Docker pull, and you got this within a second, and then Docker images, have it. So this is the way you can share the repository using the push and pull. Any questions so far?
How much it costs for the public? Means one account, one public.
0. Okay.
Yeah.
Okay. Now we'll have to spend on the question time. So here I talk about this attach, build, commit. We talk about history. We talk about the load. We talk about the login. Logout is just to log out the command. We talk about the push. We talk about the save. We talk about the tagging. We talk about all these things. So it's like most of this, like 90% of the commands which you have covered so far. Now we'll spend 5 minutes on the questions and answers.
Rajesh, I have a question here. So when you created the repository name in Docker Hub by SCM Galaxy and the name, then you use the tag command to map the existing image that you had downloaded to the name of the same repository, and
Right.
then you
It has to be
sort
same.
of.
It has to be same.
So then it created another image on the local machine using the tag.
No. I just pushed. Okay, I pull it. No, I deleted and pull it. Huh? See, I pushed it. After that, I deleted and then pull it. So it downloaded the same image if I had it in the public.
Before that, the tag command.
So a tag command will do the same image ID. It will give you the different name. It's like a tagging. Tagging, you know, in the Git, it's the same way.
So when you use the tag command, it created SCM Galaxy April doc another image on the local, right?
No. It just created a same image tagged with a different name. That's all.
Oh.
Okay. Question time.
Sublime.
Raj, like, can you give me some sample use cases where we use Docker in real time, Rajesh?
Okay. So what you have to tell me. I am not going to give you the use cases. You have seen the demo for 3 hours. Where can you see that? Where can you use the Docker?
Any appliance demonstration?
Deployment.
Any appliance demonstration?
Yes. Any app demo? See, I'll tell you a simple thing. When I ask you to deploy using you have one host with 8 gigs of RAM and CPU, 2 gigs. Now, if I say, can you run in this machine 20 VMs? You say no, it will not be possible because you can run maximum 5 VMs. Now, if you convert to the Docker technology, you can run 20 applications because your purpose is not to run the VMs. Your purpose is to run application inside the VM. Okay, so you can run with the limited infrastructure, with limited storage, limited CPU, limited RAM, limited no operating system cost. You can run more application using the same infrastructure, so you can save cost. Correct? Save cost. Now, saving time. So remember how much time you spend to create a VMs. How much time you create hours of time to create a VM, then use the chef and the puppet to deploy the application inside the VMs, and then you run it, and then the application is up and running. How much time you spend to run the application inside the container? Less than 1 second. And if you run 20 application in one Docker engine, you have to spend only 1 second for it. So saving time of in terms of deployment. So it's saving cost, saving time. That's the thing which you wanted, because you want to maximize the utilization of the CPU, RAM, storage, and operating system cost. Is that answer your question?
Yes, sir.
Okay, any more questions, please?
Rajesh, we thought actually we'll
Rajesh,
talk about the
just,
Docker Swarm.
That I'll take it the last question. Any other questions?
Yeah, Rajesh,
There,
just want to ask. Hello.
Yeah, tell me.
So yesterday, I just want to link with the Puppet thing. So yesterday we had created one module. We created modules using Puppet. So when we are deploying in the production server using Docker, so we create the images of that Puppet through Dockers.
Simple thing. Puppet and Chef will be used to modify the existing application infrastructure. Simple.
Yeah.
Okay. Here in Docker, every time you create a new containers, remember, you create a containers, you kill the container, again you create a containers. Getting my points?
Yeah.
So Puppet Chef is a configuration management tool to modify the existing infrastructure. It could be virtual machine, it could be physical machine, or it could be containers also. But here container is like a fresh application environment which you create it, and you don't care, because if someone dies, you create a new one within a seconds. Okay.
Yeah.
Any other questions? Okay, guys. So last question which I'm going to answer from my side is the scalability. If you have gone through the demo very well, you might have seen all the Docker container you are running inside the one host. Here I have one host more. That means the limitation of the Docker is only the host. If you have a 64 GB RAM, you can run only that much. Again, if you have whatever the resources you have, you can only use that one. So you cannot scale it. You cannot scale it. Okay. So for the data centers, we are not talking about 10 or 100 containers. We are talking about the millions of containers, millions of application which is running. So now the question is how to scale from 100 container to 1,000 or millions container, whatever it is, millions of container. That's the thing. How to manage millions of containers, because you don't have one container right now, you have millions of containers. So now how to automatically manage? So if let's say out of millions container, 1,000 containers dies because of some reason, so you don't care about it. Replacement should be done automatically. You are not getting up from your bed in the midnight and doing all this thing. You are not doing manually anything. Okay, so how to scale up, how to manage, how to check the health of it, and all this thing for the data centers. For the data centers, that means your whole company is running on the containers, and inside the data centers, which you have a very all the stakes are there. App containers are there, web containers are there, database containers are there, network security, every sort of containers are there. How can you manage it? The answer is Docker Swarm or Kubernetes from the Google. Okay, so this is a two different product, Docker Swarm or Kubernetes, which you want to scale it up, manage the hundreds of millions of containers, manage the data center, networking, security, auto discovery, load balancers, all these things, storage, all these things you want to do that, you have to migrate to the different tool, which is called Docker Swarm and Kubernetes. So now did you understand that where you can use it, the Docker Swarm and Docker Kubernetes? Google Kubernetes?
Yes.
Yeah.
Okay, so I just told you just a little bit of the description. Again, you have a Google oceans of the knowledge are given over there, so you can just do the things and then Google it and try to learn more. Again, if you need a training on the Kubernetes, because this Kubernetes we support actually, so you can send out an email to info@scmgalaxy.com. They will let you know the Kubernetes class timing, and you can attend with the minimal fees actually.
It's okay. Can you provide the recording? Kindly provide the recording.
Recordings will be given by end of the day, by tomorrow, and will be sent out to the email IDs.
Yeah. So Rajesh, one more question.
Mm-hmm.
Can you talk a little bit about the Docker Compose? That's one. And the second thing is let
me quickly cover this Docker Compose also. So here you forget about the Docker for time being. Okay, forget about the Docker. Think about your application stack. You are a developer. You think you are a developer. Okay, now when you have a developer, you want to create a stake of your application. When I say stake, that means you want to have one web server, one web app server, one database server, one cache server, one login server, one all these things, and this club it together, and this become your application, and this is your application, whatever the product X. Okay, product X. Now this you want to make it up and running. If you follow the physical server structure, then you have to spend 1 day. If you follow the virtualization, probably you have to spend 1 hour to create all this text from the scratch. But if you follow the container technology, 1 second. So how can you create the whole stake of one web container, application, database, all this blah blah blah, link it together and make it available in 1 second? The answer is Docker Compose. Okay, so the Compose, you have one Compose file you have to write. Docker Compose file you have to write. Docker Compose file you have to write, YAML file, and in that you decide the services. And in these services you have a web services, you have app services, DB services. You can map it the volumes, port map, all this thing, port map, you can network map, all this thing you can do in one file. You keep it ready. The moment you need a one stack, you just run it, Docker Compose YAML, Docker Compose up, down, whatever it is, and then you get this.
Yeah. So my another question is on the Docker in general, the network topology, right? Because you have only physically so many ports and so many Ethernet cards available. Mm-hmm. So how does the network, the virtualization of the network topology happens there?
So basically it's like this. If you understand the concept of the bridge, so basically every time you start the Docker engine, it's create one bridge. For you, it was a Docker 0. Docker 0 was the bridge. Any containers which you start, basically it resolve to that bridge by default. Okay, so if you want to create your own bridge, that is also possible in the Docker, and assign the container to that new bridge rather than the Docker 0. That is also possible. And the bridge, you can set it up with the whatever the IP address, range, CIDR number, and stuff like that. So that is also possible.
Okay.
Hello. One basic question. Hello. If my container application container dies, means it's lost, where the backup is?
So data will be, that's a good question. If your containers are lost, then your data Lost means due to the, if you have deleted the container, you have lost the data. But if it's not, if the container is lost due to the CPU and RAM issues and stuff like that, the data will be var docker, var lib docker. Okay, lib docker, and this one directory will be called containers. But let me tell you, you will not be able to recover the data just like the way you want it, because here you'll be having layers. Then here you will be having like this. You'll not be able to recover the data. So best way, you can mount it during the creation of this. So if your data is very important, then you have to mount using -v. For example, let me show you. Docker Jenkins hub. If you think your data is very important, during the creation of the container itself, you mount it using the -v option. Look at this. So here, all the data will be created in the host machine rather than the container. Okay.
It means at that location, we get the data and we launch the container.
Here, base machine.
Okay.
Any other questions?
Rajesh, you told while downloading the Docker image, it will get like the hashes kind of thing, right? You told you will talk about that later.
Which one? Which one?
So while downloading the Docker image, it copied the data as a chunks, right? It's not the single data.
So that's what I was talking about. My images. Images consist of the layers.
Okay.
Remember, the consist of layers. When you download the images, basically you download the layers. So you see that if you get the multiple layer, that means that images has been created using the multiple layers.
So like how Jenkins got from Alpines and
right, yeah.
got
so
from
Jenkins, you might have seen 10, 12 SHA-1 values being downloaded. That means those many layers were there in the Jenkins image that was getting downloaded.
Okay. Good.
Any other questions, guys?
So,
one more question from my side. So I was talking to, I forgot the person name. He said there's going to be an advanced class as well sometime.
No, there's a essentials class after that. There's no Jenkins topic which is missing after this class.
No, not Jenkins, actually Docker.
Oh, sorry. There's no Docker concept. Topics is missing after this session. So if you want the advanced class, that will be Kubernetes.
Okay, got it. Okay.
So after this Docker, you have to move on to the Kubernetes one.
Okay. So there you
Docker
basically
form?
talk about more deep into, I guess, networking and those things, or is it
Kubernetes is a whole new topics, whole new tools. So I'll not talk about the only networking. I'll talk about the Kubernetes concept, how it works. How can you manage thousands of containers in an efficient way by clicking few things.
Okay.
Any description for Swarm in advanced patch?
Yes,
Docker
Swarm basically is not popular, but if you want to conduct a class in the Docker Swarm, just do let Mantosh know. We can do that. But when we see that people are migrating from the Swarm or Kubernetes, we find more interest in the Kubernetes than Swarm. That's the reason we do the Kubernetes every month.
Okay, means Kubernetes, the Kubernetes baseline is same as you have taught us earlier.
No, again you missed the concept again. Here I said limitation of the Docker was to stick to the one machine. You cannot scale it up. You cannot manage a large number of containers. You cannot replace it just like that. So you need a data center related centric application which can manage the millions of containers. Kubernetes and Docker Swarm is for that perspective.
Okay. Yeah, basically for orchestration, right?
Yeah, orchestration, scaling up, management, health checkup, and networking at the greater level, load balancing, auto discovery. So many concepts are there which is required not by but for the data centers.
So when do you have that match? When do you have that Kubernetes class?
You just ask Mantosh, he will inform you.
Okay, yeah, I've already texted him. I'm interested in that because I've done basic Docker already. So interested in Kubernetes, and as you said, I agree. there is a lot interest actually outside on Kubernetes compared to Swarm.
Yeah.
I will repeat my question again. Hello.
Yeah.
You have told that the backup directory, you have told that the destination of backup directory of Docker instance. But how can we take a snapshot? Means if we have the incremental snapshots, how can we take?
Okay, so you are in the, your mindset is again in the virtualization technology. Come out of it. You don't need a snapshot at all, because here you have images with the read layers and writable layers, which is the containers. So that you have to forget about it. You don't need a snapshot because you have images. You can run images into hundreds of containers immediately. If you want to modify the images, I've told you how to modify the images and create a different images.
Yes.
So the snapshot should
Yeah.
not be here in this technology.
Okay.
Well, like final one question. The purpose of Docker Swarm and Kubernetes is one and the same, right? But mostly market is occupied with Kubernetes.
Yes. Actually, what has happened? Docker was launched. Docker was launched by the Docker. Suddenly, Kubernetes was launched by the Google in order to make the Google Cloud very popular. So they have set up all this infrastructure on the Kubernetes. So you can manage. You can set up the Kubernetes for the Docker containers. So you can scale up as you want it and with a minimal cost to orchestrate the large infrastructure. Suddenly, Docker realized they missed the race. So immediately they launched the Docker Swarm. So now the Docker Swarm and Kubernetes both are stable platform, both are well-tested platform, but there's a problem. If you use the Docker Swarm, you have to stick with the Docker engine for the container technology. But if you use the Kubernetes, tomorrow if you don't like a Docker engine, you can replace with a Rocket, which is again growing fast. So here Kubernetes, you can have a Docker engine technology, you can have it anything, but Docker Swarm is a very, very closely linked with the Docker engine itself.
Got it.
Rajesh, any suggestion for Docker certification?
So see, if you talk about the SCM Galaxy certifications, we can facilitate, but to be honest, certification is for those who just trying to convey the things, but if you practice well, and ultimate testing would be done in your interview or the project. So if you can perform all these questions, you can explain them in the greater detail, you don't need a certification. Certification is just like a resume kind of thing. But yeah, if you want to get the certification, Docker certification, you can go for Docker certification. There's a lot of materials, you can have it here, and you can try all this stuff here.
What about the person told me regarding the Facebook community?
So any questions which you don't have to WhatsApp me, you don't have to email me, you have to post in the Google Groups community, not Facebook community. So if you post the question there, within 24 hours I'll respond to that.
Are you sharing that Google community?
No, it might have been shared already, or if not, by tomorrow you'll get it from the Mantosh.
Right.
Okay, let me show you that.
Question.
Google Groups. You'll not be a part of it because that required the addition from the Mantosh side. But here, this is the group. Not everyone can join. This is the group I created last week.
Okay. Then you will adding our mail address on this.
Yes.
And how about the presentations actually here? Is that going to be shared?
Yes. All this information, whatever the email ID I'm having, I'll send it to you by end of the day or maybe tomorrow.
Okay, sounds good.
Rajesh, one final small question, Rajesh.
Yeah.
Dockerfile is meant to write new images, and whereas the Docker Compose is meant to run the images, right?
Yes. Docker Compose is basically a developer tool. Inside the Docker Compose, you will be referencing the Docker file. Okay?
Okay, got it.
Yeah. Any other questions, guys? Okay, guys,
Yeah,
with this,
sure.
I'm going to wrap it this session up because I have another meeting at in 5 minutes. So after this, we'll take it forward. Okay, any questions? Just shoot out in the Google groups. I'll answer those stuff. Bye, everyone.
Thank you.
Thanks, Rajesh.
Wonderful. Bye-bye.
Thank you.
Right. Thank you.
Thank you.
Please be kind enough to like it, and you can comment any of your doubts and queries. We will reply to them at the earliest. Want to study further? Subscribe to our paid membership to get a deep dive into each and every topic. Do look out for more videos in our playlist and subscribe to our DevOps School channel and hit the bell icon to learn more. Keep learning.